All right, so we're going to continue graphing sine and cosine graphs here, and we're going to be looking at amplitude now. So still looking at now we're going to be looking at our sine graphs here. So I'm going to still kind of do this about the same way, putting in those nice values around the unit circle. We got 0, pi over 2, pi, 3 pi over 2, and 2 pi there. So following just the axes around the unit circle and taking those nice main points there. So 3, 1, 2, 3. So now graphing this out, I'm just going to graph just a regular sine graph here first. So at sine there, at 0 there, the y value there is 0. At pi over 2, um, the y value there is 1. At pi, the y value is 0. At 3 pi over 2, the y value is at negative 1. At 2 pi, your y value is there at 0. So I'm going to connect my points here and just get my nice sine graph. So now let's go ahead and let's look at y equals 3 sine x. What does that do? Now we're going to vertically stretch it. We're not going to count or anything like this. We're going to just multiply. We're going to multiply our y values here by 3. So this point here is sitting here at 0, 0. The 0 there, the y value of that point is 0. So we got to multiply that by 3. And 0 times 3 there is just 3. So that one's not moving at all. Then the next point here, pi over 2 is up there at 1. You're not going to count up 3. You're going to multiply the y value, which is 1 times 3. 1 times 3 is 3. So now it's going to be up here. So now it's going to be at pi over 2 and at 3. At pi 0 there, multiply the y value there by 3, and you get 0. 3 pi over 2 is down there at negative 1. Multiply the y value of negative 1 there by 3. So negative 1 times 3 is negative 3. So instead of being here, we're now down here at negative 3. And at 2 pi there, it's 2 pi 0. The y value there is 0. Multiply by 3, and we're at 3, or at 0. 0 times 3 there is 0. So now let's connect those. I just kind of put these in here to kind of show us where we're at. That's not really part of the graph anymore. So there's our nice graph there. So we got y equals 3 sine x. So now if we were to actually answer the question, what's the period of the graph? The period of the graph, one nice little cycle there, lasts 2 pi. The amplitude, my amplitude is what's here in front. That's my a value. It's 3. So remember, it goes y equals a sine x. And this is always the absolute value. So that is your amplitude, ends up being the absolute value of a. So absolute value there of 3 is 3. So my amplitude is 3. And you can also tell on your graph, if I put my nice line in here, how far am I in there? 3. What's the distance in here? 3. So just to kind of remind you how to find those pieces. Reflection. So third piece I was telling you about here. So third piece here, we got, if a here is negative, so notice you got a negative sign here, and notice you got a negative sign here. We're going to reflect that over the horizontal axis. So let's practice graphing these out again. Hopefully you'll get really good at these. I'm going to do 2 of these. Pi over 2, pi, 3 pi over 2, and 2 pi. So I'm going to graph y equals sine x there first. So y equals sine x, remember 0, 0. At pi over 2, we're up at 1 there. That's looking at the y values on the unit circle. At pi, the y value there is 0. At 3 pi over 2 on the unit circle, y value there is negative 1. And at 2 pi, my y value there is 0. So if I connect this as my nice sine graph, so the red there is y equals sine x. We want to graph out y equals negative sine x. So what does that mean? We're going to reflect this over the x-axis. So if it's on the x-axis, it's going to stay there. This one up here, that pi over 2, which is up 1 there, we're going to reflect that over the x-axis. So if you fold it down over there, we're down there at -1. This one here is at pi there, or at 0 there. It's on the x-axis. It's going to stay on the x-axis because you fold it, it's going to stay in the same spot. At 3 pi over 2, it's down here at -1. If we fold that, it's going to actually come up. And then at 2 pi, it's on the x-axis, so it's going to stay right there. So now I can connect those. So really, y equals negative sine x is just that blue one there. So there's our nice graph there. It's only the blue portion. The red one is just there to kind of help us to graph it out. All right, so coming over here, we'll do the same thing here with cosine. Cosine, if you remember at 0 there, the x value is 1. At pi over 2 on your unit circle there, your x value is 0. At pi, your x value is -1. At 3 pi over 2, your x value there is at 0. And at 2 pi, your x value there is at 1. So I can connect those values there. So this is y equals the cosine of x. We want y equals negative cosine x. So let's graph that one out. So now this one that's sitting up here at 1, it's going to reflect down because of that negative there. It's going to reflect down here, become -1. On the x-axis here, or the horizontal axis, is going to stay there. At pi, we have -1. It's going to flip up. At 3 pi over 2, it's on the x-axis. It's going to stay there. And at 2 pi was at 1. We're now going to flip it down, and it becomes -1. So now we can connect these. So this one's y equals negative cosine x. So only that portion there, only that blue portion, y equals negative cosine x. So it's just flipped upside down. So that's what the negative sign there does. So I want you to work through page 429, numbers 1 through 12. So pull up your books on your iPads and you can work through those. Make sure you draw out your nice little axes for each one of your problems there. So if you want to draw them all out on the, if you want to draw out you know, each stage on the same graph, you can do that like I did. But you probably only want to put a maximum of 2 graphs on any graph. So like number 1, if you graph out the regular sine graph and then you've got a 1 plus sine graph, sine x, and you could put both of them on the same axes here, but just be careful. Maybe label them, or sometimes I'll put FG and point to it and say that's my final graph. Somehow I have to indicate which one is my final answer there. But these are your main points here, and then you're going to have the number going up this way. So how far you have to go. So you should have at least 12 graphs on your sheet of paper, one for each one of these. And then again, if you put more than one graph on there, maybe you label the final graph FG or just write out what it is. That would work. Sometimes people use colored pencils or colored pens to be able to do this as well, so they can distinguish one from the other. That works as well. So have at it.